Hello guys, welcome back to Maison African Motives, still on Mechanotechnics and form. In this platform, we shall be focusing on gear drives. That is the question paper, which was written November 2022. So we have a nice question that we are just going to talk about. We talked about other gear drives before. Now this one is a special type, which is an epicyclic gear drive. Okay. So I'm just going to explain, working with the question that we have, and I hope we are just going to understand what is happening in this case. All right, so we are given that study Fig 3 below, okay, which shows a simple epicyclic gear drive. It comprises gear wheel B, so we've got our gear wheel here with 100 teeth and a pinion. So take note, your pinion here is your A with 30 teeth and arm C. So given the arm here, which is C. All right, so that's what we have, guys. Okay, so this is our pinion, and we have got our gear wheel here. All right, that's our gear wheel, which is B. So the question is, assuming that, take note of how we attempt this one, assuming that gear wheel B is fixed. Okay, so the gear wheel here, B, is fixed. Construct a table and find the speed and direction of pinion A. Okay, pinion A is mounted on arm C, rotating 100 revs per minute about the center of gear B, about the center of gear B. All right, so this is what you're going to have. Remember, we are asked to construct a table. So this is what you do. Remember, your table, it consists of the number, the condition, then the gear drives that you have. All right, so I'm just going to put a ruler here. So I hope it's going to be clear. So I'm just going to quickly represent this one. So we have got, all right, so let's start with, all right, so let's just have this. I think we're going to have the first one, just write our information here. All right, then we move on to the number. All right, I hope it is going to be enough here. And another one, 1, 2, let's just make them 4. All right, so I'm just going to make them 4. I think it is going to be clear. All right. So let's have another one here. So sorry, guys, for taking much of your time. I just thought I'm going to be faster, but okay, it's not as faster as I thought. Okay, so this is what you're going to have. Another part, we can just subdivide now this into the first one. We don't need a much here. All right, the second one, for the condition, I need a lot. So I'm just going to leave something of this. All right, then we've got, remember, I've got gear A. All right, so this I'm just going to leave for gear A. B, all right, so we move on to B, and we have got the arm C. Okay, so this table is too much. All right, the table is too much. Anyways, that's what you're going to have. Okay, so for the meantime, I'm just going to remove this. So from this information, guys, I want us to take note. This is not a much. This is not even much, guys. This is not much. Don't worry. All right, so what you're going to have, we are going to have our number here. So let's just save our number. Then we've got our condition. That is the conditions that you're going to have. So we said we are going to have gear A. So this is our gear A. We also have gear B there. There is gear B. And we are given the arm. Take note, that was the arm. C is the arm in this case. All right, so we only have 2 gears. Okay. So if we are to take this, that the arm C, we are given that it's rotating 100 revs per minute. Okay, so this is 100. Okay, so what you are going to use is this one that you're given on the diagram. On the diagram, we are given 120. So we're going to use this one on the diagram. So which is 120, which is rotating clockwise. And remember, clockwise, that's a positive like this. Okay. So if this is rotating clockwise, which means your B is going to be also going clockwise, okay? So your B is going to be positive clockwise, whilst A is going to be opposing this direction which is anti-clockwise. So A is going to be anti-clockwise. Okay. So this is what you're going to have on our conditions. So the first one, we are given that C is fixed, okay? So you're going to fix arm C. So you're going to fix arm C. All right. Then by fixing arm C, what are we going to do? We rotate the gear B, okay? So rotate gear B, all right? And we are rotating gear B just one revolution, okay? That's the first condition. You rotate it one revolution clockwise. So a clockwise, it's a +1. So rotate gear B +1 revolution. All right. So +1 revolution or +1 rev like this, it means positive clockwise. Okay. So what we need is to have now the calculations for A. Okay, what is going to happen at A, at B, and at C? If we are to take at A, the rotation for A, take note, it is going to be TB over, that is T, so sorry, we take the rotation for B here, okay, we've got it for B, and the one for A, the teeth, the number of teeth are the ones that you use for your rotation, okay. So B is going in a clockwise, so for A, it is going to be TB over TA with a negative. So TA is going in the anticlockwise. Remember, I showed you guys TA is going in an anticlockwise. So that is going to be 100 over -30. All right, so this is the formula that you're going to have here. So you divide, you just take the number of teeth as they are, okay? So that's -100, not -100, the negative is in the denominator, guys. Okay, so let me just write it here, which is equal to 100 over, for A, we had 30 teeth, so you divide the number of teeth, okay? Which is going to give us something like -3 over 10, -10 over 3, sorry, -10 over 3, or you can write it as a decimal if you want, okay? So that's A. For B, remember B is the one that has got a +1 revolution. So which means according to the revolution, B, it's a +1. So this one is going to be a +1, which is just, we can just write it as a 1, okay? Then for arm C, the arm C is the one that we said fix, which means it's fixed there, okay? So it's a fixed point. So there is no rotation that is going to happen at this arm. So it is going to be at 0. All right. Then we move on to the second part. The second part, take note and be very, very careful, okay? You are going to multiply by X, then you add Y. So you multiply by X, okay? So this is multiply by X and add Y, all right? So we are going to multiply by X, then you add Y. So that means here, if you are to multiply by X, that's -10 over 3x, okay? We have multiplied by X. Then add Y, so we add, that's plus a Y like this, okay? We move on to this one, we multiply by X, 1 times X, that's X plus a Y, we add. Okay, we move on to 0, so that's 0 times X, which is 0x like that, which is a 0, okay? Plus Y, so 0 plus Y, we are going to remain with a 1, okay? The third condition, the third part where we are going to have a condition in this case, we are going to be referring to the number of revolution, the revolution per minute that we are given. Okay, so let's take what we have here. According to the revolutions that we have, C is at 120 revs per minute in the clockwise direction, which means it's a plus. So we've got the number of revolution for C, all right? So we've got the number of revolution for C, that's NC, which is plus 120 revs per minute in this case, which is a clockwise. That means at B, we do not have any movement that is going to take place. If C is moving, or if you are having a C movement, then at B, there's no movement. So this is going to be at 0 revs per minute. So you're going to have a 0. So what we need is, we do not know the number of revolutions which are at A. That is the pinion. That is the one that we are asked to calculate here to find the speed and direction of of rotation of P on A. So this is the one that we need to calculate. All right. So we do not know this one. So let us substitute now into this diagram. So this is NA. We do not know NA is the one that we need to calculate. NB, we said NB is a 0. So NB is a 0. So here there's a 0 here. NC is equal to plus 120. So that's plus 120 revs per minute. All right. So that's what you're going to have. So what you do after drawing the diagram, after having this table, you formulate equations in X and Y. Okay. So like I said, I'm going to show you the stages that you do to answer these typical questions. Okay. So you formulate equations in X and Y. Okay, so after that, you solve for X and Y. That's finding what? NA. So in this case, how do I formulate this? You take this X and Y corresponding minus 10X plus Y here. It corresponds to NA, which means it is going to give us NA. So you can write that NA is equivalent to negative 10 over 3X plus Y. It's an equation that you formulated, okay? You move on to another equation. X plus Y corresponds to NB, which is a 0. So NB is equal to X plus Y. And NB, that's a 0. So 0 is equal to X plus Y, okay? We move on to another one, which is the last part that we have, which is Y here, which corresponds to NC. So NC is equal to Y, and our NC is 120. So that means Y is equal to 120, or 120 is equal to Y. So if Y is equal to 120, we can find X from this equation. We can substitute Y, which is 120 here, to find X. That means if we transpose 120 to this side, that's a negative 120 is equal to X. So we have got our XC here. So if we have got X and we've got Y, then we can find NA. Remember, we want to find NA. We do not know NA. So our NA now can be calculated as negative 10 over 3 times X. Our X is negative 120 plus Y, which is 120. Okay, so what then is going to be your NA? So NA, which is our speed, is going to be 520, direct 520. So this is 520 revs per minute. Remember, this is speed in revs per minute. It's a positive, and if it is a positive, it shows that that's a clockwise. So this is 520 revs per minute clockwise. All right, so that's how you answer these typical questions if you are given an epicyclic gear like that. Okay, so we are going to have another typical question, which will be showing a train gear. Okay, a train gear. So I just hope with time we shall work on that one. From another question paper, I'm just going to look for a question paper with that so that we can just have a typical example of that one. But for this one, that's what we had, guys, if we are dealing with an epicyclic gear drive. All right, let's move on to the other part. Let's just finish everything that we have on question 5 on gear drives. 5.2, a set of spar gears meshing with teeth. Okay, if you are referring to a spar gear, guys, that's the simplest, we have got a simplest set of gears that we have. So it's like a normal gear, the simplest type of a, just think of the simplest type of a gear. Okay, that's what we refer to as spar gear. So everything about a spar gear, all these calculations, you refer to calculations of a normal gear drive. All right, so which means you're supposed to think of all those formulas that you know about gear drives, a normal gear drive, all those formulas. Okay, so let's list our information. What are we given? We are given that with each is a velocity of velocity ratio. So we're given velocity ratio 2,5 s to 1. All right, so this is 5.22. Can just list our information here, 5.22. So we are given velocity ratio in this case, which was 2,5 s to 1. All right, so let's take another information. The we are also given and a module of 6 millimeters. If the pinion has got 35 teeth, remember, in this case, I've got 35 teeth for the pinion, so we are going to have it this way. So we have got M, which is 6 millimeters, all right? Then if you are back now to that normal gear, okay, the pinion is now representing the B, the gear B. So which means your B in this case is the one that has got 35 teeth. So what do we have in this case? Okay, what do we have? What we have? This is the only information. And the question is, from this information, 5.21, we are asked to calculate now the pitch center diameter of both gears. Okay, so take note, this is pitch center diameter. Okay, so our pitch center diameter, remember, like I said, guys, we are supposed to know all the formulas from these gears. Okay, so remember that from your module is equivalent to the pitch center diameter over T, which is the number of teeth. So in this case, we can play around. In this case, we can find our PCD. 1 times PCD by cross multiplying. We are going to have PCD, which is equivalent to M times T, which is module times number of teeth. So in this case, if we are referring to the first gear, which is A, we shall have this as the pitch center diameter of gear A is equivalent to the module times the number of teeth for gear A. For B, it is going to be the same again, PCD, all right? We're going to have PCDB, which is equal to MTB. So that's what you're going to have. So in this case, our TB is there, so you can just substitute our TB in this case. But we do not have TA. So from the velocity ratio, remember that your velocity ratio here is given by the formula. Velocity ratio is going to be from the gear wheel to the pinion, okay? So from the gear wheel, we are going to have TA, the pinion, which is our TB. Okay, this we are now back to a normal gear, guys, okay? So that means we can write this as a fraction. 2,5 as to 1 means 2,5 over 1, which is equal to TA, which is the one that we need to calculate, over TB, which is 35. So we can cross multiply in this case to find TA. 1 times TA, thus TA is equal to 2,5 times 35, and 2,5 times 35, all right? You have to multiply. In this case, we are going to obtain 87,5. So this is 87,5. But we are referring, guys, to the number of teeth. So we can have this as a whole number. So this is going to approximate to 88. All right, so this can approximate to 88 as a whole number. So TA is 88, the number of teeth. So that means we can calculate our PCDA in this case, which is M, the module, which is 6. So that is going to be 6 times TA. Remember, your TA is 88. So if you multiply 6 times 88, you are going to obtain 528 millimeters. So that's your pitch safe diameter. We move on to the B. We say the module times the number of teeth for B, which is our module does not change, is 6, but the number of teeth for B is 35. So if you multiply 6 times 35, you're going to obtain 210 millimeters. So like I said, these typical questions, know your formulas, how to manipulate a formula to find what you're asked on the question. That's how you answer these questions, just like that, guys. All right, so let's check 5.22, the outside diameters of both gears. Okay, so we need the formula for the outside diameters. And what is that formula, guys? All right, 5.22, you can just have this down here. I just hope this space is going to be fine. 5.22. So we need the outside diameters, which is referred to as D, or like that. That's outside diameter. So in this case, for you to find the outside diameter, the formula is the module. It is going to be the module into T plus 2, all right, which is the number of teeth. So that means if you are to calculate the outside diameter for gear A, it is going to be the module times the number of teeth for A plus 2, like that. Okay. If you are to calculate for B, it is going to be the module times the number of teeth for B plus a 2, just like that. Okay, so this is just substitution. Remember, your M is there for A, for O, the module are 6. So it's 6 times the number of teeth for A, the number of teeth for A, in this case, we said it's 88. So that's 88 plus 2. So 88 plus 2, that's 90 times 6, which is going to be 540 millimeters, okay? The same thing for B, the module is 6, all right, times the number of teeth for B, which we calculated, which we're given as 35. So that's 35 plus 2. 35 plus 2, that's 37. Then 37 times 6, it is going to give us 222 millimeters. All right, so that's what we are going to have in this case on 5.22, the outside diameters. Okay, so that was the whole question, guys, that we had on this set of gear drives. So we have to revise as much as we can. As you can see, this was a total of 14 marks, which is a lot in exam. So all we need is to work on much question papers, revisions, so that we understand exactly what is happening and how to attempt these typical questions from Meson African motives on Mechanotechnics Info till we meet again.